All right, and we are live. Hello, everybody.
Hello, hello.
Hey, Graeme. Hello, Twitch. Hello, everybody who's listening in for today's coding session with Graeme. And I'm really excited to here together. Like Graeme will do some live coding, and I will ask some questions and also observe the Twitch chat. So you can ask questions as well. I will be moderating questions and making sure they get answered here from Graeme. You can ask anything about Micronaut. You will not find a better expert on Micronaut than I have right now here. You can also ask everything about the GraalVM. Yeah, so Micronaut was recently here. There was a new release of Micronaut, and I'm now switching over into and Graeme, take it away. Like, what's new in the latest release of Micronaut? This is 2.5. So maybe you can
Yeah,
explain a little bit the versioning of Micronaut. It's like 2.5 is sort of it's a feature release, but it's not it's not a major. It's not from 2 to 3. Like how do you decide these releases?
generally we follow semantic versioning.
Hmm.
We're putting out, minor releases, and the expectation there is that we don't break anything, right? From
Right.
we shouldn't break anything, right? So
Right, which
if we
means
break
if I
something,
was on 2.4 and I moved to 2.5, I shouldn't have any.
that's right. You have no upgrade problem. So we don't change any API. We don't make any breaking API changes. We don't anything that might constitute a breaking change. It does not go into a 2.x release.
Hmm. Cool.
Um, and then obviously for Micronaut 3, there's a bit more freedom on that front, which we're working on right now. But still, you don't want to break a lot of stuff
Right.
generally.
Yeah, makes sense. Makes
So
sense. But yeah, what's new here in 2.5? We have so I
okay,
also.
well, there's a couple of kind of nice little niceties, like folks who are not familiar with non-blocking IO and reactive programming and NetT and so forth have been asking a long time. Okay, I just want to receive an input stream and get Micronaut to kind of do what it has to do to run it on the IO thread pool and so forth. So that's a small little feature that's kind of handy, and these are just little things, being able to redirect from HTTP to HTTPS automatically. But I think the bigger deal about this release, which was to make sure Micronaut was optimized for GraalVM 21.1, and that all the build plugins default to that version when building inside Docker, for example. So and in this case, there wasn't a huge number of changes for us to adapt to 21.1, which is great. And in addition to that, of course, 21.1 also supports JDK 16.
Right.
So JDK 16 is now available as an option on Micronaut Launch, which is a project generator that you can generate your projects with. Gradle 7, which is what we're defaulting now as well for Gradle, if you choose that as a build tool in Micronaut Launch, so that we can support JDK 16.
Cool. And today you're gonna use 16. Are you gonna use 11 for?
I'll use 11 just in case we want to build a native image, but
Right.
because we're not quite there yet in terms of native image building on 16.
Okay.
But it's exciting that it's an option that for JIT mode. And another big theme of this release was Micronaut Data. So an immense amount of work went into Micronaut Data, particularly around JDBC and RTDBC, to support the notion of immutable entities, right?
Okay.
So Java 16 records, clearly immutable entities, and these now really work really great in Micronaut Data JDBC and R2DBC. You can read and write immutable objects from your database, and it will deal with all the mapping and mapping them from rows and so forth and back and forth, which is really nice. And again, a few other little nice things like in our micrometer support,
Right.
we had support for adding @time to any method, which would generate the metrics for the timing for any method, and now you can also use @counted.
Yeah, so Micrometer just it's like this framework that you're using there in order to do like connections with all sorts of metric frameworks, right?
Yes, and one of them is Oracle Cloud Monitoring, right? So in this module, we have a new version of the Micronaut Oracle Cloud module, which supports cloud monitoring and basically publishing all your metrics to the cloud monitoring service on Oracle Cloud. So you can use @time, then @counted on your methods, and it'll push all that data in terms of the metrics to whatever metric system you're using, whether it be Prometheus or Cloud or Dropwizard or whatever metric system.
Yeah, I think Micrometer I think has a ton of it's like 10, 20 different ones that they support.
Yeah, we have a module for so many different services.
Right.
And of course, there's a whole bunch of other dependency upgrades in this release to the latest versions of Kafka and Liquibase and Elastic and gRPC and so on and so forth. So yeah, evolving the 2x line forward.
Cool.
And getting it ready for the latest versions of Java, which is cool.
Right. So in 3.0, just like a little bit as a preview, like I mean, you will do some changes that are kind of more like breaking or something, or like what are you most looking forward to change there for 3.0 that you cannot currently do in a minor update?
So there are a number of things. Obviously, removing deprecations. We have a whole bunch of methods that are marked as deprecated, and they're just hanging around on the 2.x line that people shouldn't be using. So just cleaning the code base up and removing the deprecations is going to be a nice thing to do. But in terms of major changes, we plan to move from RxJava 2 to Reactor as the default Reactor framework for Micronaut 3, so that we can integrate better with things like R2DVC and be more familiar to Spring users. And also support advanced cases of distributed tracing a whole lot better, and in terms of reducing the complexity that is required. Because RxJava is great, but it's quite complex to instrument for microservices in terms of distributed tracing. And we have a working solution that works, but it's it's very complicated to maintain. And we're now with RxJava 3 out anyway. We would have to have made some kind of breaking change to move from one library to another. So that'll be the big one. But I think that in general,
yes, and I'm getting rid of the deprecations, which means if I'm on Micronaut 2.x, I obviously should try to avoid deprecated methods. So I'm also then ready for the 3.0 update.
Yeah.
Right?
Yeah. Absolutely.
All right, cool, excellent. That's a cool overview of what's currently happening in Micronaut. There's a question chat. Would you mind giving some intro on Micronaut? We will not do a lot of intro on Micronaut today. There will be other sessions that are really starting maybe from scratch regarding Micronaut. But I think Micronaut is so easy and intuitive to understand that I think during the live coding, you don't need prior knowledge of Micronaut, I think, and I myself I'm a more a compiler VM runtime person who has enjoyed writing a few Micronaut applications, but not many. So I will make sure to keep Graeme on a level that I can understand. And if you have any questions on something that you would see on the screen during the coding, let us know on the Twitch. And another question, Chad, is: do you have plans to support RSocket? That's a very interesting question. Yes, right there.
So that's another reason why we want to move to Reactor, because it will make supporting things like RSocket a lot easier. So yes, RSocket is something that we're looking at long term, and in general, moving over to Reactor will help that. Move towards that.
Yes, and just a few words what RSocket is, because I didn't know about that. I heard about it 1 or 2 months ago. What's RSocket? Just say 2 sentences, Graeme.
It's like a wire level protocol implementation of reactive streams. So that instead of using another protocol such as HTTP, which may not be really well. It's generally not optimized for the reactive streams model of back pressure and so forth. It's essentially a Y-level protocol for expressing back pressure and so forth.
Right. So you can have two services like communicate with each other in reactive ways, and it will handle like the details underneath. And
yeah, so that's what it is, and yeah, it's got some traction. Not doesn't seem to have a huge amount, but it's certainly interesting, and particularly if you want like something more low level. Yeah, we certainly are looking into it, and there's so many things that developers want us to support, and we do. Micronaut has great integration with things like gRPC and GraphQL, and so many different types of APIs and protocols that you have to support. But it's
cool. Yeah, there's so many words, so many technologies with different words. It's like really hard to. It's a very complex space. But this is good. It's a very diverse ecosystem. You have many choices, and then using a framework like Micronaut is then helping you to deal with this, because some of the things Micronaut provides is kind of like abstractions on top of the actual protocols to make it easier for you to switch them and make choices.
Absolutely, yeah. I mean, it's Micronaut is designed to be cloud native, although that's really an overused word.
Right.
But cloud ready in terms of being able to have a level of abstraction over the infrastructure such that you can switch from one cloud to another just by reconfiguring your application, and we have great integration with all of the clouds, from Oracle Cloud to AWS to GCP and so forth. So
it also helps basically making your app cloud agnostic, which is nowadays I think very important. And so there is another question from Tony Trago. Is Micronaut written mostly in Java, Groovy, or Kotlin? I think it's Java, right?
It's 100% written in Java.
Right.
We have individual modules for the Groovy and Kotlin languages that provide some niceties for developers that use those languages. But all of the core is written in Java.
Yeah, and I think one of the reasoning there is that as a framework that is used by many other possible languages, as a framework that is used by Java developers, by Groovy developers, by Kotlin developers, I think it's better to write the core framework in the Java language, and then have it, because I think there could be oddities when, let's say, it will be written in Groovy and you want to consume it from Java, like an API, for example, right?
Yeah, it's definitely, you just have to look at, for example, the HTTP fiasco when they moved from Java to Kotlin for the newest version. Right. It doesn't benefit, you basically have to, pull in the Kotlin standard library, and that might result in dependency conflicts, and things might change. So, for libraries, you have to maintain a smallest number of dependencies to avoid conflicts and so forth.
Exactly.
So in Java.
Yeah, that's why for Micronaut itself, it's good that it's written purely in Java. But if you want to write in Kotlin, Micronaut certainly supports Kotlin and supports writing that the user of Micronaut can write its applications in Kotlin or Groovy. Right?
Yeah, we have a very enthusiastic Kotlin user base as well, with many folks using Micronaut and Kotlin together. I think it's probably helped by the fact that we went multi-language with all of the code examples. So every single example that we have in our documentation is multi-language and continuously tested with ASCII Doctor. So I think that has helped getting folks familiar with different languages to use the framework, and and we do have interest. I think our Micronaut's highest voted issue on our issue tracker is actually support for Scala.
Right.
So, which we don't currently support. because we would have to write the Scala compiler plugin for it. But one day maybe.
Right. Yeah, exactly.
So
Yes.
the more languages, the merrier.
Yes, absolutely, absolutely. The more languages, the merrier. That's cool. Yeah, another question: will Groovy be supported by GraalVM? And so I think what you mean there specifically is GraalVM native image. So GraalVM in its default configuration being a cheat mode, of course, we run Groovy applications, and we run them actually pretty well. Meaning our cheat compiler is really good in removing abstractions from the Groovy language. So your Groovy application would typically run faster on GraalVM cheat. Similar like Scala applications, for example, run typically fast on GraalVM cheat. Now the question is, can we make a native image out of a Groovy application? And this is a little bit more difficult because Groovy is so dynamic in nature. Now Groovy has some compiler configurations that make Groovy like generate more static code, but it still typically creates more issues, and you would need, it is like a real an expert thing to try to make a Groovy app, I would say, compiled here with to a native image.
Yeah, I've seen it done with the tracing agent. Somebody did get it successfully done, but it's definitely not for the faint-hearted. I think it's because of the amount of reflection and the dynamicity that happens with Groovy.
It's not a good fit. And for Java and Kotlin, it should work much better. Kotlin should be supported as well nowadays. We fixed there some issues over the last year with Kotlin. So there's another question, interesting one from Tony Drago, and I'm also interested in that one. Would Micronaut be a good choice for a traditional monolithic app where the pages are generated on the server as opposed to an SPA? I'm not sure what SPA stands for.
Yeah, single page app like with JavaScript front end. Yeah. Absolutely. And we have folks that are, the thing about Micronaut is, it's really a general purpose framework. So you have folks that are using it for, command line apps. You have folks that are using it for IoT apps. You have folks that are using it even to build Java effects and Swing applications, right? Which are, pretty much always monoliths, right? And we do have really good support for, if you go to, I think it's Micronaut projects, Micronaut views, we have support for a whole bunch of different view rendering technologies in Micronaut views. So we have support for like Thymeleaf templates, server-side rendering of Thymeleaf, handlebars, velocity, free marker. Actually, Rocker is the template engine we actually use in Micronaut Launch to generate project templates for when you generate a project from the Micronaut Launch UI. And Rocker is very interesting from a GraalVM perspective because it's completely statically compiled and reflection-free, right? It's very GraalVM friendly because you don't have to configure anything, right? Native image friendly.
It's native image friendly, exactly.
Yeah, and I think soil enclosure is also the same. But having said that, all of the different implementations that we test, all of these against GraalVM. So every single integration with all these view rendering frameworks are supported with native image. It's just if you plan to use Thymeleaf inside instead of something like Rocker, you'll need to make sure that whatever model objects you pass into the view are registered for reflection, which is easy to do.
Right.
We have great server-side view rendering support, and folks building monoliths as well with it.
And with native image, you always need to configure the reflection. And I think one aspect regarding here that is a little bit underappreciated here is this like restricting the reflection only to what is configured is actually also a security benefit. because there's many
Right.
security bugs that have occurred due to unlimited reflection, unlimited deserialization. So in some ways, configuring here a reflection is not only making your native images smaller and more efficient, it also makes sure that you are not creating some security issues by allowing deserializations or reflective excesses that you were not planning for.
Absolutely. I agree 100%. So, there's been so many CVEs related to like, random serialization of objects that,
Right. Exactly. Yeah. Absolutely.
really.
Absolutely. Yeah. So bad. But it's an annoyance that also gets you like a security benefit. This is which is cool. Yes. One more follow-up question from Tony Drager. If Micronaut is a web framework, how would it make sense to use it for a command line app or Swing app? So why, like, what would be a benefit to use Micronaut?
So that's the common misconception about Micronaut, right? It's not just a web framework, right? It's a general application programming stack,
Yes.
right? So it features at the base level. It's very modular. So at the base level, it features support for dependency injection and aspect-oriented programming and configuration injection and all these things, and none of these are specific to a web app, right? You have dependency injection and AOP have benefits within Swing JavaFX applications, command line applications. So it's it's a general purpose application framework, and in fact, you have people that are building message-driven microservices that again have no UI or HTTP layer whatsoever.
Right.
But, just have a main method and listen to a Kafka stream and process data. Right.
Yeah,
so,
exactly. So there's many features here, and the HTTP aspect of it is just one small part of it.
You can build gRPC apps, you can build functions, serverless functions. It's very much not just a web framework, right?
Exactly. Yes. Another very interesting question in chat, Ramaka, from Ramaka. When compared with Spring, what advantages do we have using Micronaut? So let's see. That's an interesting question. Let's see if Graeme can answer that without throwing any shade at any other project. And but
okay, well,
what's your pitch to somebody who's like, should I use Spring or Micronaut? Why Micronaut?
As you can see from the intro here that on Micronaut that it's actually created based on lessons learned from building Spring Boot and Rails applications. And the major difference between Micronaut and Spring is Micronaut computes all of your framework infrastructure at build time in a completely reflection, runtime proxy, runtime bytecode generation, dynamic class loader free manner. So that results in a much smaller runtime. When you build a Micronaut application, it's like a 10 megabyte jar file as opposed to Spring, which is like 30 megabytes or something like that. And because the runtime is smaller and leaner, that leads to like other benefits in terms of, for example, debugging. Micronaut has much like smaller stack traces because it's no reflection, right? It's just direct method invocation everywhere, which is leads to again more optimized applications. And the other major benefit, which I'm sure you'll see in the demo as well, is compile time checking. So, with Spring, most of the time you have to run your application to see whether it works or not, or fails or works. Micronaut will catch most framework level errors. So if you use an annotation incorrectly, or if you use a feature incorrectly, it will fail at compilation time with an error that points to the source code or where something went wrong, right? Which is a big productivity boost.
Right.
And then the massive reduction in startup time as well, because we're computing everything. Micronaut starts up much quicker, which has knock-on effects to how you build your application. It's faster to run integration tests. You don't need to mock anything. The application just starts up really quickly and it's easy to test.
Right. Mm-hmm. Yeah, cool, excellent. Yes, and I kind of really can recommend people just trying out Micronaut on some example, and then see the difference and experience the difference in this example. And I think there's like this, the mindset of Micronaut and GraalVM native image is sort of very similar in the sense that we want to do a lot during build time, which has benefits for startup, but also has benefits for developer productivity, because we can do like checks of types and checks of your application at build time during your development, and no need to wait for later. And some of the tools that we are building around this, including this Visual Studio Code plugin, are trying to help us out.
Yeah, so I'm like super excited about our new VS Code tooling that we've been working on, with the NetBeans guys, for GraalVM and Micronaut. If you want to grab this toolkit, basically you have to go to the marketplace and you will find it under there's the GraalVM extension pack, if I remember correctly, this guy here. You just install that and you get all these great tools, including Micronaut support, and it's really cool. The tooling has really come on in leaps and bounds in this latest release. This 21.1 release is awesome.
Cool.
So I can start demoing.
Yes. I think you're all done, and we have talked enough now theoretically. Let's go into actual coding here.
Yeah. Okay. So this is the Micronaut tools kind of intro page that you get when you install the tooling, and you can create your Micronaut project directly from VS Code. And by the way, if you're obviously I'm doing this tooling because it's tooling and it's new and it's awesome. But if you're an Intellij user, Micronaut is also integrated into Intellij, so a lot of these same wizards and so forth exist in Intellij, and Intellij has really great Micronaut support as well. But anyway, you can pick your Micronaut version, the type of application you want. You can select a local GraalVM SDK, or if you don't have one, you can easily download and install one. Define a name for your project, a base package, the language that you're interested in using, and then you can start picking out some features. So I'm going to pick some features here. I'm going to pick Micronaut Data JDBC. I'm going to pick Oracle Database, which I have running locally. I'm going to pick OpenAPI as well, because I want to show you some OpenAPI stuff. And we'll pick Kubernetes as well. And so you get all these different features that you can include when generating your application, and you click OK, and you can choose your build tool, your unit testing framework, and then it will generate an application for you. So I'm going to create a new Twitch directory for this demo and create it in here. And then we'll just import your project into VS Code automatically. It takes a little bit of time to launch the language server and import the project with the Gradle tooling. But basically now you have like a Micronaut project, right, ready to go. And before I begin.
Right, cool. And yes, and the features that we selected, those are now in the dependencies, right? So
right, yes. So
maybe if you go to your build Gradle.
So if I look at my build.gradle in here, if I look at my build.gradle, you can see that. Let's see. That the dependencies that I chose, for example, Micronaut Data JDBC, is in here, as well as all the other things that I have chosen. Right. So, which is pretty cool. Okay, so I'm already ready. Let's see. Resolve project problems.
Yeah, So this is this main class of Micronaut, where you always have this static void main with call to Micronaut.run, right? Like I was wondering, you know, maybe in some future version of Micronaut, like this could you generate this class so we don't need to write that, because it seems the same for almost every Micronaut app.
Yeah, so absolutely we could end up generating the main method and so forth, and that's a possibility. But
yeah, I mean,
you know, generally,
for a large application, you might want it, right? Yeah, that's fine. Just think about a use case where I'm using, for example, Micronaut with JBang, which is this tool where you write everything in one file, and then I think it could be quite nice to avoid that. But yeah, for a large app, this is yeah, for sure. Anyway, yeah, nice to have a application class where you can also then put the Open API definition on, right?
Right. So let's see. I'm just going to open up terminal in a minute here, and hold on a second. I'm going to go into Micronaut demos, Twitch demo, and basically now you can see I'm in that directory I created, and what we can run the application that.
There's a fun comment on Twitch. Never thought I'd see the day when Graeme picks JUnit over Spock. From Tony Traeger.
Yeah. I you know, normally I would actually one of the reasons is, you know, and it's actually, I'm pushing it and I'm super excited about it, but it's one of the features that's coming in the next iteration of our VS Code tooling, right?
Right.
So
to have Spock support, right? Okay.
Right.
In that tool.
Right. So hopefully that will, you know, come in the next version, which, you know, I'm looking forward to, and have like some like Spock tooling, which will be really good. So you know, when you for some reason this is saying resolution failed for some reason when I import this.
Yeah, somebody made a comment in the chat that this the class is in the wrong directory somehow. It says here Java, main Java, but that should still be okay, right? But it looks almost like, yeah, it should be okay.
Yeah, for some reason when I import this into my project, yeah, it's giving me some error, which is weird.
Right, it just says on the top, right? I think he didn't recognize like the. I think the package and the directory name is like different.
Package and the directory name is different.
I think that's the error, right? Because it says on the left it's this Java / something. I know that this is the structure you would typically have as Gradle, but I think here the tool might not be. Maybe we should maybe we should generate this with Mr. Maven.
Yeah, it's doing something down here where it's saying resolution failed for some reason. Let us basically regenerate it, like you said,
right?
Because I think I probably have some weird thing going on here. But
it says here Groovy missing property execution, yeah.
Which is problematic, but yeah. Okay. So for the moment, what I'm going to do is close this, and we're going to CD up, and we're going to remove that for the moment. And we're going to go into our Micronaut tooling again.
And maybe let's do the generate Maven, or?
Yeah, let's try that.
I think the Maven should work more
Yeah. Okay, 2.5 Micronaut application demo example Java. So we were going to do JDBC.
Yes.
We were going to do Oracle database. We were going to do what was the other thing we were going to do? We were going to do Open API, and we were going to do Kubernetes, right?
Yes, Kubernetes. That's right.
Okay, so there we go. Click OK.
And now Maven, I think that should be.
Yeah. Right here.
Yes.
Okay. Okay, so we have my Micronaut application here, and I imagine it will download everything. And basically, what we can do straight out the bat is run the application from the IDE, so I can start it up, and the Micronaut application will start up and connect to my local running Oracle database, which is really nice. And straight away within the IDE as well, we have test execution available. So I can come in here and I can run these tests. And actually, I'm going to stop that test at the moment because I want to use a local running Oracle database. So I'm going to run this and just run it against my locally running Oracle database. There we go. Okay, hold on. Let's do Maven W. Okay. So and I get everything set up immediately for me with indicators of when things pass. So you can see here that I'm getting these green ticks. If I go to show test explorer, I can see something worked. My test passed, and I can actually run tests directly from here, right? Which is really nice. And if I were to make this test fail, so if I were to say assert false, and run it again, you'll see, from VS Code, we get this really nice inline error reporting. So you can actually see the assertion directly where the thing went wrong, right? Which is really cool.
Cool.
That you get this kind of inline error reporting directly in the IDE. So I'm going to make the test pass again. And we should be good to go. And what I'm going to do is I'm going to go back to my application here, and we're going to start doing a few things. So one thing you can do in Micronaut as well is if I do Maven W and then run my application locally, you'll also get, some developers really like the ability to edit code like this, and make a change in here, and basically see the server automatically restarting for you on every change. So that's what you can, that if you do mn/run to run the application, you can get that development experience. Now, I don't actually personally use that experience very much, because I'm the type of person that comes in and it's like continuously running my tests, and in general, I spend time in my test suite. But for the kind of people that enjoy this experience of having it changes reloaded automatically as you type your application, that's how you do it.
Yes, is this a question in the chat from? And is there an equivalent for Gradle for this reload, or is this only maybe in Phoenix?
Yes, it is. If you do Gradle run --continuous,
it does the same thing. So we support Gradle continuous build essentially.
Yes.
So you can basically directly run your application from your IDE in this tooling, which is really cool, and experience that. So now I'm going to start actually building the applications. So what I'm going to do is I'm going to create a new book entity. Let's call it. Let's do com.example, and it's going to be a book. What we can do is we can make this a mapped entity that maps to the database, and we can have, for example, a ID that is of type long, and maybe a title of the book, and maybe some pages, the number of pages that it has. Right. And the IDs provides you some really nice support for like generating constructors and automatically out the box. Right. And we can generate getters for these as well.
Right. And you said that long with a big L because an ID could be null as well, but you say int pages.
Yeah, exactly. So in general, what you will want is this to be a generated value that comes from the database. Yeah. And you can make it generated by identity, for example. And you want it to be your database ID, but you want it to be nullable, right? Right. So you can annotate all of those with nullable, and you could potentially add another constructor here, that would ease, creating books with a null ID out of the box. But what you want to do there is, in that case, you would want to annotate this one with creator. So the framework knows which one to invoke when creating your entity from the database.
Makes sense.
In general, what you have here is an immutable entity, and you mentioned Java 16. So this is a whole lot nicer with records, right? Because you don't need all these getters, and it's more succinct and so forth. So with that, I have like an entity. And from there, I can create like a repository.java file, and package com.example. And with Micronaut Data, we have the notion of CRUD repository. Let's see, where you can extend these existing interfaces like CRUD repository. And what that does is it gives you the ability to do CRUD operations, right? And you just supply the entity type and the ID type, and then you need to annotate it with JDBC repository and specify a particular dialect. And with that, I have a repository. So let's write a test and see how that looks already. Whoops, we definitely don't want to call it that. We want to call it book repository tests, right? Yes. That would have been not good. And what you can do is you can make this a test, like so, and it can be a Micronaut test. And from there, you can inject the book repository, like so. And we can have a test in here. Not one of those. There's different test annotations. Let's do test count for the moment. And we can import this. You want the JUnit Jupyter version for JUnit 5. That's another common mistake, right? Importing the JUnit 4 version in live coding demos.
I see. So the Jupyter is the JUnit 5 version, or how is...
Yeah, the Jupyter is the JUnit 5 version. Yeah. Okay. So yeah, now we're going to say assert equals repository dot count. I assume it's going to be 0 to begin with. And if we run this test,
semicolon at the end.
Yeah, that's going to fail to compile. If we run this test now, you'll see that the test should essentially pass, which it does. And of course, if I change this, that would result in a test failure.
So this is, already set up to, create my entity in the database and allow me to query and so on and so forth. So what you can do is, test out saving an entity. So we can save in your book, for example, the Stand, which is a great book, by the way, which is a very long book, that one. And we can save it, and then we, I imagine we'll have exactly one book in the number of books that are available. So that kind of it's that simple to like essentially persist a book.
Right.
Now one of the things you can do as well with Micronaut Data is you can say find by title, for example, and the Stand. And with the tooling, we can just create that method in my repository. There it is.
Oh, okay.
Currently it's returning void.
You need to make it to template.
And yeah, and we've created the book. So that there we go. And we can extract that into a variable, and that will return my book. And what we can do is we can do assertions set not null book, and essentially make my test pass once again. So
cool. And just to maybe take a small step back, and like what is happening here is like this repository is kind of the Micronaut abstraction for a database, right? And
exactly.
And then
persisting and retrieving entities.
Exactly, that's right. And then like and the benefit of here using a Micronaut here is like if I then want to change the database that's running in the background to a different one, or like I get all this benefits for not directly depending on a database driver.
Absolutely, yeah. So you essentially get all the logic for free in terms of automatically making this a read-only transaction, querying the database with the correct SQL, binding to the book entity, and it just works out of the box, which is really nice. And
then you don't need to deal with all these details of SQL, etc. For you, it just looks like a nice Java class with all the right methods. So it's really cool.
Yeah.
So there's one question: what object relational mapping is used in Micronaut? Is it Hibernate? Are we using Hibernate?
So we support both JPA Hibernate, but I'm actually using the JDBC implementation, which is a simple data mapper. And the nice thing about Micronaut Data JDBC is it's implemented with Micronaut primitives such that it'll read and write objects to the database without using any reflection, right? Or any runtime proxies or anything like that. And the other nice thing is the compile time checking. So, if I were to, for example, misspell this, like so, and I try to, run my test, for example, what you will see is that the actual, well, if I just do Maven W compile, you'll see that you get a compilation error with the appropriate compile error, which is somewhere here. So you cannot query entity you cannot query entity book on non-existent property title, right? So you get really interesting compilation errors happening.
Right, and it tells you, it tells you that immediately at build time. That's cool. Yeah. Another question is, what database is used during the tests? Does it magically switch to H2, which is an in-memory database, or does it use some other database during the tests?
Well, one of the differences with Micronaut Data as well is that it actually pre-computes your SQL at compilation time to execute. So it doesn't wait, unlike things like GraalVM and so forth, which GraalVM or Hibernate, which wait until runtime to figure out what SQL to execute. Micronaut actually at compilation time works out what SQL to execute. But it's really easy to switch out to H2, especially in a mocking scenario. So, I could define a mock bean here that essentially mocks my book repository like this. Like that. And what it can be is another book repository, mock book repository like so. And what you can do is define a interface mock book repository like so, that extends from the normal book repository. And you can say that this is a JDBC repository for H2, essentially. And it will, it'll essentially something like this, right?
Right. Okay. But yeah, let's break that down now. What magic you did here, Graeme, for the non-Micronaut experts like myself.
In fact, you probably don't even have to do that. You can just do this mock bean.
Right. Okay. So you use here the mock bean annotation to tell Micronaut that in the you might need the extra one there.
Yeah, I think I have. Oh yeah, that now it's working. Okay, so
we're telling that. Let me repeat that to you, Graeme, and you tell me if I'm correct understanding.
Yeah.
So the mock bean annotation tells here, like, within this test class, if you are supposed to create a book repository instance, you should not create an actual instance, but an instance of this mock.
Yes, that is correct.
Class, right? Yeah. Yes, and the mock class is kind of like a repository where I change the dialect to H2.
Yes.
Cool.
And the only other thing you would have to do is provide a test URL, because right now in application.yaml, it's pointing to Oracle. You would just provide a application-test.yaml, which reconfigured this to work with H2 essentially.
Okay. And this and how would it then tell which YAML to use there? Like if well, it's pretty easy to figure out. If you go to one of the great things about Micronaut Launch is that it can be used as like a reference. So if I go to features and I select JDBC as a feature, by default it sets up for H2. So if I click preview here and go into source main resources application.yaml, here we have the H2 configuration. Yes, makes sense.
So I can copy that and then create a new application test.yaml file.
Yes.
Like so,
right.
With my H2 configuration, and this will essentially load the test configuration for H2.
Yes, and because of
override everything.
Right, and because of your file name application-test, Micronaut picks that up as the test config automatically.
Yeah.
Okay, makes sense.
Essentially, yeah.
Cool.
So so in fact, right now it's using the test environment. So yeah, it's really that simple.
Yes, comment in Twitch chat. So the magic is using create drop to clean the Oracle database running on localhost for each test. Is that accurate? Or like?
Yes, right now I'm using create drop, but you could set it up to use test containers, and in fact that's the default way to. But you have to essentially publish your own Oracle container image and so forth.
Right.
So yeah, in this case, it's pretty easy to replace the functionality in Micronaut with a different repository
cool.
at build time.
Yes, excellent.
Okay, so yeah, setting up data like this, during my test, one of the nice things about Micronaut is by default it will actually roll back transactions between tests. You can disable that as well if you set transactional false, in which case it won't automatically roll back of the transaction after each test. But you may also want to set up data on application startup. So one of the things you can do is define an event listener that listens for Micronaut's startup event, like so. And
yes, and just
and
because
basically,
you did another thing here, which was just very subtle. You put @singleton on the application class. What does that do?
Yeah, so that makes it a bean definition. So by default, it's not a bean.
Exactly, and that means that when the application starts, there will be one instance of this created.
Exactly, there will be exactly a single instance of the application class. So it's quite common to use application as well for startup logic and other things, which is one of the reasons why we don't generate it, because people often want to customize things, right? And customize the way Micronaut starts up. But yeah, Micronaut supports things like @transactional, so you can make a method transactional, and because this is now a bean, I can inject into here the repository that I'm working with and generate a constructor, which I have done, right? And from here, we can move that logic that we had, which was, setting up a book, or maybe setting up multiple books. We can do save. You can either do save, and save a couple of books like this, or you could do a batch update where you do repository.save all. And in which case you would want to pass in an iterable, so you would say raise as list, and pass in these two guys, one here and one here, like so. And
that's one.
probably I'm missing.
Yeah. Yes. Exactly. Okay now.
Am I missing something? Iterable raise. Unclosed string literal. It's just catching up.
Decided,
import. Import. Okay.
Right.
So there we go. I code too fast for the editor, it seems. So
yes, exactly. Absolutely.
So yeah.
Yeah, cool. Yes. And in terms of fast things you did here, the constructor injection here, because you're injecting now the repository. But here you didn't do the constructor injection. Is there a specific reason why on the book repository test you're not doing constructor injection? Because constructor injection is kind of supposed to be preferred if it's possible. Yeah.
So I'm going to switch back to using my Oracle implementation, and so yeah, you can absolutely use constructor injection. So I can make this a final book repository and generate a constructor for it. That is supported in JUnit 5. So you can I can remove in that case remove that unused import.
JUnit 5 it's supported, but before in earlier versions of JUnit it was a problem because JUnit wanted to have.
Yeah, it was. I think it was relative. You still see a lot of field usage of fields in JUnit tests because people are so used to using fields. But it is true. In fact, you don't even need this constructor. You can in fact just do this, which is even more simple. And that is even cleaner, right?
Yes, that is even cleaner. I agree. Yes.
Yeah.
That is very cool.
So
cool, excellent. Yes, there's one question check regarding test containers. What is the status of test container support in the latest version of Micronaut Test? there's some complaint that in the first versions of Micronaut, there were some issues where test containers were not able to expose the port. Like, did you fix some issues related to test containers lately in Micronaut?
I don't know of any issues with test containers. We have extensive test container support. So if you choose particular feature, like depending on, like, for example, if I choose Oracle as a database and preview that, it sets it up with test containers using the particular driver. And if you switch to something else, I don't know, like MySQL, for example, and preview that, it also sets up test containers for MySQL. So, and that should just work in terms of the settings that you want to do.
Okay.
I do know that you can obviously do it manually. So so for example, if I wanted to set well, let's just do if I wanted to do set up a container manually, you can use, there is actually a library for I think it's called Test Containers JUnit 5. So let's
okay, but that's fine. I think
it's already on the class path. It's already on the class path.
Yeah, that's an answer for, like, yes. So it should be fully supported. If there's any issues,
so what you can do is you can basically do test containers on the test, and what you want to do is make this test. JUnit has a test instance lifecycle where it creates where you want it to be per class. And I do this quite often. And then you implement test property provider, like so, and you implement this interface, like so, to implement the properties that you want to provide to Micronaut. And you can use map of in Linux to could be, I don't know, data sources .default.url. Whatever you want to inject, and then you can add a static generic container for new generic container, like so, with your test with the image name that you want, and annotate this with app container. And as far as I know, that I'm actually using this today. I have been using this recently, and you can reference this container, and you can say container .get first mapped port or something like that, and probably have to do string.value or whatever, because that returns an integer. And basically pass whatever properties that you need to configure in your application in this way. And this definitely works because I've been using this earlier today. So I'm not sure what other issues.
Yes, no, cool. Yes. It's just a general questions, but you already have the full demo, like including test containers programmed out. That's cool.
Yeah.
Yes. One question regarding this is on the chat. Would containers start before or after the test bean is being initialized? What if one of the beans relies on a container? For example, GCP pops up emulate a random port that needs to be retrieved. I don't understand the last question, but the earlier questions maybe you can answer them. Like when are the containers starting? Are they started before or after the test bean is initialized?
Before everything, yeah. So basically what I demonstrated now in the video works 100%. In fact, I have another project that I'm working on where I'm using that approach to do it, create it using test instance lifecycle per class, creating a and I believe for Spark you can use setup spec and so forth, or shared container variables, and yeah, just retrieve the map port and pass it to Micronaut via the configuration, and then everything works.
All right, cool. Cool.
But if you have particular issues, do report them, and we would love to know.
Absolutely. Cool. Excellent. Cool. Thanks. Thanks, Graeme. Yes, let's move on here.
Okay, so what else? So basically, yes, you can, with Micronaut, then at that point, create a new book controller, like so, and controllers in Micronaut are very easy to write. You can map it to the books URI. Essentially, this is going to way in which you can expose endpoints, and we can inject that into my controller, and write an index endpoint, for example, that lists all the books, and does something like return repository lists, find all, something along those lines. Probably we would need to import list, and actually find all, I think by default returns an iterable. So you would need to go into this guy and override the find all method to instead return a list rather than an iterable. And now I'm able to list all my books, and you can write another endpoint, for example, that exposes books by titles, and find a particular book by title, return repository dot find by title, like this.
Yes, here you use a specific thing in Micronaut where, like, you can in the URL you say here / and then the title name, and that's then parsed into the argument.
Yeah, that's it. And if you misspell this,
right,
you get a compilation error, right? Before Micronaut even starts up. So we have this type checking of the fact that you're using the correct thing here.
Right.
And you can also easily add a post request, to add new books, like so, and save, and you can basically receive the variables like this, and it will consume those from JSON. And you can call save new book title pages. And one of the nice things about Micronaut is the built-in support for validation. So I can say the title should not be blank, for example, and I can say things like the minimum number of pages should be I don't know, 50. Who knows? And it will validate those components. So add imports for those, and you get automatic validation of your endpoints. And Micronaut's validation support is baked right into the framework. It's not like based on Hibernate Validator, so it's completely reflection free, efficient and small. So there's no need to depend on anything else. It's just baked right into the framework, which is really nice. You can also, of course, apply validation rules directly to your entities as well. So I can come in here and then say this, shouldn't be blank, and this should be min 50 or something like that. And that will work as well in terms of defining the ability to have post requests. And of course, because Micronaut is based on Netty, this controller is interacting with a essentially blocking API in JDBC. We do have support for R2DBC as well, where you can do fully non-blocking SQL, but I haven't had time to demonstrate that just yet. But basically, what you probably want to do is make this execute on the IO thread pool. And that will make all the operations in this controller execute on the IO thread pool. An alternative to that is to come into
what is the default if I don't do that? If I don't specify anything on the controller?
The default is to run on the event loop, so you clearly don't want to block that.
Right.
Yeah, and it's really nice the code completion that you get as well. You can actually configure Micronaut to choose to always run operations on the IO thread pool, right? So if I do micronaut.server.thread selection equals IO, it will switch to running them always on the IO thread pool. And you can also do things, you can reconfigure the IO thread pool by just specifying that it's type fixed, for example, and maybe that's the 75 threads or whatever. So that all of these settings are environment specific. Depends on what workload you're running, the number of processes in your machine, also kinds of things. But essentially, those are the options in front of you in terms of offloading those to a different thread pool. So now I have a controller, and it's already been exposed of HTTP. Writing a test for this is really easy as well. What you can do is create a new book controller test.java, and we can make this a book controller test, and it can be a Micronaut test as well. And Micronaut has a built-in HTTP client, so you can actually define an HTTP client that looks like this, and that's valid for the scope of your test. And we can actually just replicate these endpoints, and add imports for that, import that. And now we can add a test. Void.
So do I need to replicate those functions, or can I somehow create a construct where the controller is extending the client or something, so I don't need to specify those methods twice?
You can if you want. So I could extract an interface here and
a common super. Okay. Yes,
yeah,
a common super.
A common interface between the two.
All right, makes sense.
We don't recommend exporting that as a library, because you're not supposed to couple microservices in that manner.
Right.
But basically, yes, you can. I can already at this point list all my books, and I can say assert assertions. Did I import the right assertions? No, that's the assert equals to book start size.
Right.
And we can run this test. And if the demo gods are with me, which they were not with me earlier today, then in terms of setting up my original project,
but here they are.
My test bars.
Excellent.
So here they are. I'll have to work out offline on what thing has been corrupted on my machine to mess that up. But yes, this is working. So so yeah, I've injected my book client into my test, and I'm listing the books. and yeah, it is working. So you can add HTTP logging if you want to see like the detail of what's going on. So I can have a logger that's called io.micronaut.http.client, and I can set that to a trace level, for example. And I can run this again, and I imagine I will probably see in the debug console the trace output from things going back and forth. So you see the JSON coming back from my request, which is pretty cool.
Cool, yeah, absolutely. Absolutely. This is really small amount of code. There's a lot of things going on.
Yeah, a lot of things happening, and a lot of different components going on. So I also want to demonstrate how cool the Micronaut support for Swagger is, because one of the advantages of Micronaut, Micronaut basically processes your source code, and that because we have access to the source code, we can report errors, compilation errors to Java C automatically. But we can also actually get access to parts of your source code. And one of the things we do is we actually do that for Swagger. So I can actually configure exposing my Swagger resources. So I'm just gonna cheat a bit because I have my cheat configuration. Micronaut.router. Okay, so I'm going to expose my Swagger output, and I'm also going to create.
So just a few sentences on for me, I'm not so familiar with all of these technologies. So Swagger, why are we doing Swagger, and what is the purpose of using Swagger here?
So Swagger is a technology that lets you document your APIs for microservices, right? So you'll see that when I do clean and then run, when my application compiles, I believe
it will generate some Swagger definition files that we can share with others, right?
Yeah. Did I actually add the Swagger? Yes, I did. Okay, so it's going to generate some Swagger definitions. So actually, if I just stop for a moment, you'll see in my target directory, in my classes directory, is meta-inf Swagger demo /YAML. So my Swagger has already been generated from my API compilation time.
I see there's even this minimum 50 there, like all the constraints on the properties are even there. It's pretty
right, cool. Exactly. So it interprets all of the constraints. So if I open up my browser here and I go to Swagger index, you can see, whoa, I have my Swagger API, and I already have books, which I can, and like you said, in the post request, you can see already that the schema of an example value of what you need to send. Now, this is all generated from the source code at compilation time, which means you don't have to, Micronaut doesn't have to process all of your code at runtime again to figure out how to generate this at runtime, right? It's already been generated at build time, which is really cool. But where it gets really cool is when you start documenting your API. Yeah. So so for example, I can come in here and I can say with Javadoc, I can say this finds a book by the title, and it has a param called title that is the title of the book. Should never be blank. Maybe if you had like constraints, whatever. Yeah, so we can document our API. We can say, you know, this should list all of the books. And now, when I go back to my browser, you can see, oh, look, lists all of the books.
There. Yeah, cool. So you're also parsing there sort of the comments.
Yeah, it's really because we're able to process source code. We can pull your Java comments out and include that in your Swagger API, which, you know, the title of the book should never be blank. Yeah, cool. We can try out this API.
So this is this is running via annotation processor as well. So the annotation processor has access to the contents of the comment.
Correct. Yes. So one of the advantages of processing source code as opposed to processing the bytecode afterwards is we have access to all of the, you know, everything from the comments to and we can do amazing stuff like this, like automatically produce your Swagger documentation, which I think is
yeah, that's really cool and important for the microservices to communicate to others what's your interface. Yeah. But so the other way around, I think currently doesn't work for Micronaut because there's this Swagger plugins, I think, where from the definition you can grade automatically the controller, right?
Yeah, so we actually, that's something that we definitely need to look at supporting, is like generating, but that's like generating like clients, right? Generating clients from Swagger.
Right.
That would be nice. And it would make it like a great contribution if somebody wants to implement that. But yeah, it's definitely something we need to look at supporting at some point.
Yeah, I think
but the fact that we, yeah, for sure, and build on our existing, like, you know, if you could like one microservice compile time building the Swagger, and then the consumer, you know, compile time, parsing the Swagger, and, you know, building the client. That's very cool stuff. Yeah. So, you know, the other thing that is cool with Micronaut is, like I said, the whole you know, cloud native thing. So with configuration, you can create different configuration for different environments. So you may have seen. And by the way, I'm just going on. Are we like running up against time, or is this?
It's like yes, we can go on until the last viewer is like tired, and so far the viewers have been quite loyal here, and but still, I think we covered a good section, and I think we will have more sessions in the upcoming weeks, etc., on Micronaut and Yuan, and I think we can save some of the content also for future sessions. So yeah, let's just, I mean, I think this is so what we did here basically in like under an hour, like 50 minutes, like it's a full-blown like microservice with the Swagger definition, database connection, test, even the test container config. So it's really, it's quite amazing how little code we had to write and how fast and productive this was. And I think that's the key message here. Also the key benefit or goal of Micronaut, I guess, to just make developers more productive here, and to get them like some joy when they like implement cloud applications.
For sure, yeah.
So yeah, I think like we can, like, you know, maybe if there's more questions in the Twitch chat, now is your last chance to kind of have Graeme talk about more things. But overall, like, yeah, there's also always like the next session where we'll maybe build upon this demo, or maybe we have another topic.
Yeah, I think we should take this demo to the next level of like, you know, deployment and building native images and that kind of thing. I think I've already covered quite a bit, but I think there's more. We can expand on this app. We can
involve more features of Micronaut.
Cool. Yes, yes, yes. One area actually that I'm very interested in, because I still don't quite get the best practices in that area, is like if I now have a client-side graphical user interface of sorts, or like a single-page app in JavaScript, like how would then be sort of the best practice to connect here? So maybe we can cover this topic like in an upcoming stream of how I then like do kind of the full stack development here, and what would be the best practice frameworks that I can use here on client and side also to then interact with my Micronaut app.
Yeah, well, I think that's definitely an interesting topic. I think one of the challenges is the best practice framework changes every 6 weeks in the JavaScript world.
Right. Of course.
But
yes, I like Svelte, by the way. I think you should be aware of Svelte, because I think Svelte is like the natural friend of Micronaut.
Absolutely, I think Svelte is the most impressive one I've seen. The fact that it's also compilation time processing.
Exactly.
Is whenever I looked at React, it just seems like so verbose. So it was quite refreshing seeing how like concise and simple Svelte was.
Yeah, cool. Yeah, maybe we can do a Svelte front end and an upcoming stream at some point. That will be very exciting, I think. Yeah. So there's one more question on the chat, which is there any Spring Batch like project for Micronaut? So there's Spring Batch, and is there something similar?
There is not any. Well, there is. We have the ability. It depends what you mean by batch. Obviously, that we have the ability to schedule jobs and job scheduling, and sometimes that is all you need. And I think somebody actually wrote a library that supports distributed job scheduling as well. But no, we don't support batch. And I think I also think that in general, we don't want Micronaut to become implement every use case in the world.
Right.
Yeah.
So we can exactly, absolutely. Yeah, so that's good. That's good. Cool. Yes. So there's another comment in the chat. Very interesting one is that Vue.js version 3 will also use compile time processing. So that's interesting, actually. I should look at that.
That's awesome.
But it's cool. It's cool that also like now in JavaScript framework world, they're realizing the benefits of doing more with compile time, and then it will be like compile time native image, compile time Micronaut annotation checking, and
this is a trend that's happening like all over the place. As far as I think. Even the .NET guys are starting to.
Yes, I saw that .NET guys are envious of GraalVM native image for Java, and they're like, oh, we need something as well.
So this is happening.
Absolutely.
And I think the technology is just going to head that way, and we're building more efficient, more smaller applications, smaller runtime.
And not pay the cost of like starting like making the same computation over and over again. In the end, you really like saving CPU cycles if you have a reasonable production deployment where you're starting often, and like you're really saving just CPU cycles here, and ultimately that should be a general goal to avoid here sort of a waste of CPU cycles where like the same computation is done over and over again. And
yeah, for sure.
Mm-hmm. Cool, excellent, cool. That is a good time to conclude the stream here, I think. Thank you very much for everybody for watching the stream. Thank you specifically for everybody who was submitting questions on the Twitch chat. I think it was great to see that this time we had like a lot of questions and very interesting ones as well. I hope to see you again on a future stream. We'll be online again next week. If you have some specific topics that you would like to see us cover and talk more about, you're welcome to reach out to us. And so thank you everybody. Thanks for the feedback, and thanks Graeme for coding so quickly and a great demo. And it was really interesting for me also to follow you along and get to know and have the opportunity to really ask sort of you whenever I don't understand anything. So this is really a luxury. Thanks Graeme. Thanks everybody, and everybody have a great day and a rest of the week. Thank you.
Thanks a lot. Bye.